Hey friends, so in today's lesson, we're going to deal with applications of nonlinear systems. Now, I know I've said this in other sessions we've had together before, but applications is just a fancy way of saying a real world contextual problem, okay? So really, we're going to take everything we did on the last two lessons, which was solving by graphing and then solving by substitution and elimination, and we're going to now first be given a context, have to build our own system, and then solve it like we have been solving it the last two lessons, okay? So what I want to do with you today is just walk through a few problems together, and then you'll have the rest of the time to kind of work through some of the problems on your own, okay? Like always, as we go through this sort of stuff, it would be really helpful on your end to read through the question with me, but then pause me, try it yourself, and then put me back on and see how you did. And we can kind of compare notes that way. You make the connections you need to make in 20-1 by trying it. Don't be afraid to try something and get it wrong. Sometimes you need to get it wrong, and then you need to see why you got it wrong in order to know why the right way is the right way, okay? So please make sure as we go through this together, pause me, try it yourself. Nobody's watching your work but you right now, so try it by yourself, then put me back on and see how you did, and where you struggle, make sure you can kind of see why I did it the way I did. And if you can't see it, connect with me, okay? All right, so let's try the first one here. The sum of two integers is 5. When 10 times one number is subtracted from the square of another number, the result is 125. I'm just going to hide myself there so you can read the full question. Create and algebraically solve a system of equations to determine the two numbers. Okay, so when we're building, the very first thing we have to do is define what our variables are, right? If you don't define what X is and what Y is, or what A is and what B is, whatever you want to do, but if you don't define that, everything else you say in the question is meaningless, okay? So the first thing I've established is we're going to let X equal our first number, and we're going to let Y equal our second number, okay? Now we have to come up with some equations. So I know that the sum of two integers is -5. Well, that means X plus Y equals -5. There's my first equation, okay? Then the next statement said when 10 times one number is subtracted from the square of another number, the result is 125. So I have to square one of my numbers. I'm going to choose the X value to be the number I square, because I know what to do with an X squared, right? It'd be kind of problematic if I introduce a Y squared right now, because we've got an X and we've got a Y squared and we've never really dealt with that. Okay, so I'm going to go X squared minus 10Y, and then that'll equal 125. So my two equations are X plus Y equals -5 and X squared minus 10Y equals 125. Now, I ask myself, okay, how do I want to solve this? Do I want to solve this by substitution, or do I want to solve this by elimination? It doesn't matter at the end of the day which one you choose. I think for this guy, substitution is probably a little easier. I could just move that X over here, and I'd already have isolated Y in the top equation, okay? So I can say that Y, oh, sorry, my mouse is gone. I can say that Y is -X minus 5, just by taking that X and moving it to the other side of the equal sign. And now what I'll do is I'll take the value for Y, that expression, that -X minus 5 expression, and I'm going to plug it in for this Y right here. Okay, so I'm going to rewrite the equation, but instead of saying X squared minus 10 times Y equals 125, I'm going to say X squared minus 10 times, well, what's Y now? I can write it as -X minus 5. Okay, so in place of that Y, I'm going to write -X minus 5. Okay, and that would look like this. So now I have a one variable equation to solve. This only involves X or X squared. Okay, I want to clean it up a bit by distributing the -10. So this is going to be X squared plus 10X plus 50 when I distribute the -10 onto the -5 as well, equals 125. okay? Now I can see I have a quadratic. I've got an x squared and I've got an x term and I've got a number. In order to solve this, I want to bring everything over to one side so that it equals 0. And then I'm going to see if I can factor it. So I have to subtract the 125 from both sides. That's going to leave me with x squared plus 10x minus 75 equals 0. So now I'm asking myself, hey, can I factor this? Can I find two numbers that multiply together to give me negative 75, add together to give me that 10? Well, yes, I can. That would be 15 and negative 5. So I've got x plus 15 and x minus 5. Now, this is the zero product principle. We've been talking about this with a couple of different factoring situations. Either the x plus 15 could give me my 0, or the x minus 5 could give me my 0. If the x plus 15 gave me my 0, then x equals negative 15. If the x minus 5 gave me my 0, then x equals 5. Okay, so my two solutions right now, the two x values of my solution, are negative 15 and 5. Now, you want to be careful here. Sometimes we see these two solutions and say, oh, those are my two numbers and I'm done the question. Well, no, you're not. What these guys actually represent is the two x values of two different solution sets, okay? I still need to get the y value that goes with each of those x values, okay? So there are actually two solution sets to this question. One of the numbers is negative 15 on. The other one of the numbers is 5 on, but I got to get the matching numbers that go with them, okay? So I'm going to take one of my original equations. I'm going to go back to that x plus y equals negative 5. I'm going to take one of my original equations. I'm going to plug in negative 15 and get my y value out. And I'm going to plug in 5 and get my y value out. Okay, so that's what I'm doing right here. When I plug in negative 15, I get negative 15 plus y equals negative 5. I'll add 15 to both sides, and that will give me y equals 10. So that one gives me negative 15 comma 10. So one possibility for those two numbers is negative 15, 10. Okay. Then I'm going to try plugging in 5, and that's going to give me 5 plus y equals negative 5. I'll have to subtract 5 from both sides, and that will give me y equals negative 10. Okay, so my other possibility would be positive 5 with negative 10. Okay, now, whenever you are asked a question, a word problem, an application, you need to actually answer the question. So the question is determine the two numbers. So my conclusion is, okay, the two numbers are negative 15 and 10, or 5 and negative 10. Okay, negative 15 and 10, or 5 and negative 10. Okay. All right, ready for another one? You totally are. Okay, I can tell. It's written all over your face. Okay, the perimeter of a rectangle is represented by 8y, and the area is represented by 6y plus 3 square meters. Determine two equations in terms of x and y, one for the perimeter and one for the area of the rectangle. Okay, so we're going to start with perimeter. I know that the perimeter is the distance around an object, okay? So I'm just going to hide my head here for a second. I can see that this is x plus 8. Oh, I didn't really want to do purple and purple. Hey, I can do x plus 8 like that, but I know that this is also x plus 8. So I've got two x plus 8s, and then I can see this is x plus 6, but I know I have another x plus 6 over there. So I have two x plus 8s, and I have two x plus 6s. And that will be the perimeter, okay? And I know that the perimeter is 8y. So my first equation for perimeter will be 2x plus 6s plus 2x plus 8s, and that will equal 8y. Now, I want to clean that up, so I'm going to distribute the 2's. That's going to give me 2x plus 12 plus 2x plus 16 equals 8y. Then I can say, okay, 2x and 2x is 4x, 12 and 16 is 28. So now I'm looking at 4x plus 28 equals 8y. I'm just trying to make this as simple as possible. Finally, I see all of those are divisible by 4. So I'll go ahead and do that. Might as well make my number simpler if I can. X plus 7 equals 2y. Okay, so a simplified form of the perimeter will be x plus 7 equals 2y. All right, now let's tackle the area. The area of a rectangle is base times height, or length times width, however you like to call it. So that'll be x plus 8 times x plus 6. And I was told that the area was represented by 6y plus 3. So I'll set that equal to 6y plus 3. Okay, so that would look like this. And now I can multiply all this out. So this will give me x squared. I've got 8x and 6x, so that'll be 14x, and then plus 48. Okay, now to clean things up, I'm going to subtract 3 from both sides just so I get all my numbers in the same spot. So that'll be x squared plus 14x plus 45 equals 6y. Okay, so that gives me the formula or the equation for perimeter and the equation for area. The next part of this question says, okay, determine the area and the perimeter. So now I have to solve the system. I have two equations with two unknowns. I'm going to set this up and solve it by elimination this time. So I've put my x squares on top of x squares. There's none down here. And then my x's on my x's and my numbers on my numbers and my y's on my y's. I want to make the y's say the same thing so that I can eliminate them and I'll be left with a quadratic that I can try and solve. I've got 6y on top and 2y on the bottom. So if I take the bottom one and multiply by 3, that will give me 6y. Okay, so I'm going to communicate that I do that. I'm just going to arrow over and say, okay, that bottom guy is going to get multiplied by 3. So that's going to give me the same on the top, but on the bottom, I'm going to have 3x plus 21 equals 6y. Okay, so now I know my 6y and my 6y will go away if I subtract them because they're the same sign. So I'm going to subtract everything down the column. Okay, so x squared minus nothing is x squared. 14x minus 3x is 11x. And 45 minus 21 is 24. Then, of course, 6y minus 6y is nothing. So that leaves me with 0. Okay, so now I'm left with a cute little quadratic to solve. Okay, do I know two numbers that multiply together give me 24 and add together to give me 11? Sure I do. They are 3 and 8. So I've got x plus 3 and x plus 8 equals 0. That puts me at the zero product principle. Either my x plus 3 is 0, and that would mean x is negative 3, or my x plus 8 equals 0, and that would mean x is negative 8. Okay. Sorry. Now, I ask myself, do both of those work in context of the question? The negative 3 would work. I can plug a negative 3 in for x here, and I can plug a negative 3 in for x here, and both of those are viable dimensions. The negative 8 doesn't work, because if I plugged a negative 8 in here, this would be negative 2, this would be 0. Those are not viable dimensions for a rectangle. Okay, so the negative 8 is out. The negative 8 won't work, as it would give me a negative dimension when used with the x plus 6. Okay, so I need to see both of these solutions because I need to know you understand there is two solutions. That's part of the problem. And then part of your solution has to be that you also know whether both of those are viable in the meaningful context that you were given. Okay, so don't just in your head say, oh, negative 8 is not going to work, so I'm just going to say negative 3. Because if all I see is negative 3, I'm going to wonder, did they know there was two solutions? Do you know what I mean? It's really important in your communication. And this is something that when you get into 30-1, Alberta Ed will actually look for in written responses. You need to show all the solutions and then show an understanding that certain solutions don't work. That's all part of the communication of your knowledge of the question, okay? Okay, so if x is negative 3, I'm now going to plug that in and get my y value out. So negative 3 plus 7 is 2y, so 4 is 2y, and y is 2. Now, the question didn't just say solve it, it said determine the area and perimeter. So now that there's a few different ways I can go about doing this. I could plug negative 3 in to my x's on these dimensions and figure out my area and perimeter that way. Or now that I know y is 2, I could just go back and say, okay, the perimeter was 8y. So if the perimeter is 8y, that's going to give me 16. And the area was represented by 6y plus 3. So if I plug in 2 for that y, I get 12 plus 3, which is 15. Okay, so now I want to conclude the perimeter is 16 meters and the area is 15 square meters. Okay. You got this, guys. You got this. Don't worry. Okay. Another mathematical directing word to talk about. Interpret. Interpret means to provide a meaning of something, present information in a new form that adds meaning to the original data. Okay. We're going to use that in the next question. Now, the next question is wordy. Don't look at a bunch of words and shut down, okay? It's just giving us the information we need. I'm going to hide my head and read it through with you. Suppose that in one stunt, two Cirque du Soleil performers are launched toward each other from two slightly offset seesaws. The first performer is launched, and 1 second later, the second performer is launched in the opposite direction. They both perform a flip and give each other a high five in the air. Each performer is in the air for 2 seconds. The height above the seesaw versus time for each performer during the stunt is approximated by a parabola as shown. And their paths are shown on a coordinate grid. Okay, so that's all the information that we have. Now, we're just going to break it down and go through some questions together. The first question is, determine a system, I'll hide myself there for a sec, determine a system of equations that models the performer's height during the stunt. Okay, I have two parabolic shapes. I know how to do that. I know that I can go to the equation y equals a x minus p all squared plus q. I can plug in my p and my q. I can find a friendly number, plug it in for x and y, and solve for a. Okay, those are all things we did in Unit 1. The great thing about 20-1, once you learn something, it's fair game in any other question for the rest of the semester. Okay, so this is not a course where you can just write a quiz and say, oh, okay, I'm done with that material, I can forget it now. You will always need to be able to do this stuff as we continue. Okay, everything builds on everything. So we're going to build an equation for the green graph. I know for my green graph here, I've got a vertex at 1, 5. So my p value is 1 and my q value is 5. And I'm going to use this friendly point here of 0, 0. Plug that in for x and y so I can solve for a. Okay, so I started by saying y equals a x minus 1 squared plus 5. So I just put in my p and my q. Now I'm going to put my 0 and 0 in so I can solve for a. I've got 0 minus 1 here. 0 minus 1 is 1. 1 squared is 1. So this is actually just going to simplify to a. And I need to subtract 5 from both sides. So I'm going to get a statement that reads negative 5 equals a, which means the equation for the green graph can be represented by y equals negative 5. I now know my a value. X minus 1 squared plus 5. Okay. Now we're going to do the same thing for the blue graph. So the blue graph, I have a vertex right here that's at 2, 5, and I need a friendly point. I'm going to happen to choose this one, 1, 0, but you could have easily chosen 3, 0, 2. That would have been fine. Okay. Okay, so I'm going to go the same way. I'm going to start with my vertex form. I'm going to plug in my vertex, which is 2 and 5. And now I'm going to plug in my friendly point. My friendly point was 1 for x and 0 for y. And now I'm going to solve for a. So again, I'm going to have to subtract 5 from both sides. I'm going to have a negative 5 on the left side. Inside these brackets, I have 1 minus 2 all squared. Well, 1 minus 2 is negative 1, and negative 1 all squared is 1. So I again am just left with a here, 1a. Okay, so I again have a statement that reads negative 5 equals a. And so my final equation for the blue graph is y equals negative 5, x minus 2 all squared plus 5. Okay, so now this is my system. We were asked to create a system. A system of equations is more than one equation. I've got a system now. Okay. All right. Now, the second part says solve graphically. Okay, so go ahead and throw this in your graphing calculator. Okay. Obviously your picture should end up looking like this, right? And so if you're struggling with your window, This is a great time to practice window settings. Think about the one that was given to you, right? You want to go from like maybe -1 up to 3, maybe in scales of 0.5 for your x's. And then for your y's, you want to go from probably -1 up to 7 if you want to follow the same window. Okay. And then you want to solve it graphically. If you're a TI kid, you go second trace 5, enter, enter, enter. If you're a Casio kid, you go F5, F5. And you should get a point on the bottom of your screen that says x equals 1.5 and y equals 3.75. Okay, so the solution is 1.5 bracket 3.75. Now, you may ask the question, am I allowed to say this in decimals? The answer to that for this guy would be yes. If this was on a test, I would probably give you a little bit more hint with that, a little bit more direction with that, I guess is a better way to say that, because I would say round to the nearest 10th or something like that. And that's your biggest hint that you don't have to answer an exact value. You'll recall in other conversations we've had together, I have said, if there are no rounding instructions given, answer as a fraction or answer as a radical, answer as exact value, okay? 1.5 and 3.75 are okay here for a couple of reasons. Number one, they are exact value. They're not rounded values there. Number two, we're talking about length and time. You know, I don't tend to tell people, oh, I can hold my breath for root 30 minutes. Do you know what I mean? We have no concept of what root 30 minutes might be as far as a duration, but we do know what 1.5 seconds is going to feel like. Okay. By the way, nobody can hold their breath for root 30 minutes. If you stop and think about that and think about what decimal that is, that's your homework. How long did I just say I could hold my breath? And I was blatantly lying, by the way. I don't think I can hold my breath for more than 10 seconds. But I digress. The last section of this question said, interpret what your solution is. So what does the 1.5 mean? What does the 3.75 mean? Well, it means that at 1.5 seconds, both performers will be at 3.75 height meters, okay? They're 3.75 meters high. It doesn't actually mean they ran into each other, because this doesn't tell us about, like, they could be side by side, they could be facing each other. If they were facing each other, they'd slam into each other and fall down, okay? But the question, we assume they're close together because the question did say they were able to give each other a high five, okay? So at 1.5 seconds, both of the performers will be at a height of 3.75 meters, okay? All right, you guys are doing great. Two more questions I want to talk to you about. Here is the second last one. Determine the values of m and n if 3, 4 is the solution to the following system of equations. Okay, well, if I gave you the solution, 3, 4, that's the value for x and for y that work in both of those equations. So that means for both of those equations, you can plug in 3 for x and 4 for y. Well, okay, so let's just say that in our note. If 3, 4 is a solution, I can plug it into both equations as values for x and y respectively. So I'm just going to do that to the first equation for a second. And I notice that that equation has no m. So I actually very quickly can solve for m here. 3 squared is 9, so I have 9m minus 4 equals 32. I'll add 4 to both sides, and that gives me 9m equals 36. Then I just have to divide by 9. So m is going to give me 4. Okay, so now that I know that m is 4, I can say, okay, time to go to this equation. I can plug in a value for m, I can plug in a value for x, and I can plug in a value for y. Well, that's everything but n. So now I have the ability to actually solve for n. Okay, so I'm going to write that equation down here. And I've got 3 squared. I plugged in my 3 for x, and I plugged in my 4 for y. 3 squared is 9. I'm also going to plug in my 4 for m. So I end up with 4 times 9 minus 5 times 4 equals n. So 4 times 9 is 36 minus 20, and 36 minus 20 is 16. Okay, so m will be 4 and n will be 16. Okay, that one wasn't too bad, I don't think. All right, good job, guys. The perimeter of a parallelogram is 28 centimeters. Its area is 10y centimeters squared. Okay, first, write a simplified equation for the parallelogram's perimeter. Well, I know that the perimeter is the distance all the way around. I'm going to hide my big old face for a second here. So I'll have 2x minus 6's, one here and one up here, and 2y minus 2's. What I don't need right now is the x minus 2. Okay, so the perimeter will be 2x minus 6's, and 2y minus 2's. Okay, now I'm going to clean, oh, and the perimeter equals 28 because I was told that in the question. Okay, so now I'm going to clean that up. This is going to give me 4x minus 12 and 4y minus 4. Okay, negative 12 and negative 4 is negative 16, so I can combine that, but I'm also going to add 16 to both sides so that I get all my numbers on the other side. So that's going to give me 44 equals 4x plus 4y. But then I might as well look at that and say, okay, I can divide a 4 by all of that and just make the numbers a little smaller. So 11 equals x plus y is going to be the simplified equation for the parallelogram's perimeter. Okay. Part B is the parallelogram's area. Well, the area of a parallelogram is base times height. Now, the definition of base and height are 2 dimensions of a shape that form a 90-degree angle. Okay, so for this parallelogram, we're looking at the 2x minus 6 and the x minus 2. I'm just going to hide myself again for a sec. The 2x minus 6 and the x minus 2, because they form that right angle with each other. Okay, so that's our base and height. So 2x minus 6 times x minus 2 has to give me the area, which is represented by 10y. Okay, so now I multiply that out. 2x times x is 2x squared. 2x times neg 2, I'll have neg 4x and neg 6x. So when I combine that, that'll be neg 10x. And then negative 6 times negative 2 is 12. So I've got 10y equals 2x squared minus 10x plus 12. Again, I want to make my numbers as simple as possible, so I can divide everything by 2 here, just to make those a little smaller. So 5y equals x squared minus 5x plus 6. Okay. Okay, then the last part of this says solve the system. So again, I look at these two equations, my 11 equals x plus y and my 5y equals x squared minus 5x plus 6. I'm gonna do substitution for this guy. I'm gonna take that green guy and isolate for y. So I just have to bring my x over here. It'll be 11 minus x there, okay? And I'm going to take that 11 minus x is y. So where I see the y in the blue graph, that says 5 times y, I'm going to substitute that y with 11 minus x so that it says 5 times 11 minus x, because 11 minus x and y are the same thing. Okay, so now I distribute the 5, so that's 55 minus 5x equals x squared minus 5x plus 6. I'm going to bring, well, take a look at this. If I add 5x to both sides, that actually wipes out the negative 5x, okay? The negative 5x was actually balanced on both equations. And so now I'm just left with x squared and a number. So as soon as I'm left with x squared and a number, I want to get the numbers on the other side of the x squared so that I can just square both sides. So now I'm going to say, okay, let's subtract 6 from both sides. And that's going to give me 49 equals x squared. Okay, now to get x, I take the root of 49. A reminder, because you're taking the square root, it could be plus or minus. So x could be plus or minus 7. And then I need to ask myself, do both of those answers work within the context of the question? The -7 does not work because that would end up giving me negative lengths. So I'm only going with the +7. So I'm going to take, so I have to say that -7 doesn't work in the context of the question, as it would produce a negative length. Okay, so now I'm going to take the +7 and plug that into one of the original equations. I'm actually going to plug it in right where I left off on that 11 minus x dude. So now I have 11 minus 7 equals y, so y is 4. So the solution to the system is 7, 4. Okay. I could have asked you what the dimensions of the parallelogram are. If I had done that, you would have just plugged in the 7 for your x's and the 4 for your y's. Okay. All right, so that's where we'll stop for today. If you have any questions as you're going through your homework, make sure you connect with me. Again, I want to just gently remind you, when you're setting these things up, it's really, really important to start your question saying let x equal or let y equal if they haven't already been defined for you. Okay, super, super important. All right, guys, have fun, and I will see you for our next lesson. Take care.